This lab is all about salinity. There are a variety of methods that can be used to measure salinity. The most basic method is to measure the mass of a seawater sample, evaporate all of its water in an oven, and then measure the mass of what's left over as dissolved solids. We can use these data to solve for the mass-based definition of salinity. As you can imagine, this method is relatively slow and certainly not very easy to perform on a ship. Alternatively, we can measure for salinity using a meter, based on the fact that the conductivity of an electrical current through a liquid is highly correlated to the liquid's concentration of dissolved solids, like sodium and chloride. In other words, the saltier solutions will better carry or conduct an electrical current. A conductivity meter measures precisely how much of its battery's current is conducted across its two small metal plates when the plates are submerged in a solution. This measure of a solution's conductivity is reported in units of either microsiemens or millisiemens. This conductivity-based method is relatively fast, easy, and accurate, but neither microsiemens nor millisiemens look very useful for directly estimating salinity. To get from these measures of conductivity to our desired measure of salinity, we need to calibrate the conductivity meter to accurately relay what it measures to what we want to know. To calibrate our meter, we're going to measure the conductivity of 4 solutions of known salinity. These are known as calibration standards. The measured conductivity of these calibration standards is then plotted versus their known salinity to produce a conductivity versus salinity calibration curve. We will use this curve later in Part B as well. You will record the conductivity meter readings from the video into tables 1 and 2 of your lab. Be sure to have your lab and a pencil ready. In Part A, our goal is to create a calibration curve based on our calibration standards. Later, we'll use this curve to determine the salinity of 6 solutions based on their measured conductivity. We're going to use this conductivity meter to measure the conductivity of these 4 calibration standards. These data should be recorded into Table 1. So on the meter, the conductivity are these larger numbers. The units are here. Right now it's sitting in microsiemens, which is a smaller unit than millisiemens. I'll let you know when it changes to millisiemens. And this is the temperature of the solution in degrees C, which you will not need to record. The probe looks like this. It measures the conductivity across the 2 plates that are down here, and this measures the temperature of the water, or the solution. The first calibration standard has a salinity of 0 parts per thousand salt. We can anticipate this to stay in microsiemens, and it's basically just deionized water. So I insert the probe into the solution and gently swirl it around until the measurement stabilizes. This can sometimes take a little bit because this is a really small number. It should be very close to 0 when we convert it to millisiemens. We'll say the conductivity of calibration standard 1 is 128.9 microsiemens. We'll convert that to millisiemens in the lab. Calibration standard 2 has a salinity of 12 parts per thousand salt. This is a larger number, and so we can anticipate this to be, its conductivity to be in millisiemens. Put the probe in the solution. So range means that the probe is changing units. Now we're reading in millisiemens. We'll let this number stabilize. So the conductivity of calibration standard 2 is 15.08 millisiemens. Calibration standard 3 has a salinity of 24 parts per thousand salt. So we're changing units. We're now reading in millisiemens. So the conductivity of calibration standard 3 is 26.08 millisiemens. Calibration standard 4 has a salinity of 36 parts per thousand salt. So the conductivity of calibration standard 4 is 41.24 millisiemens. Pause the video here and complete part A of your lab before moving on to complete part B.